The Lion King, a classic Disney movie that almost everyone has had the pleasure in viewing. Everyone was scarred when Mufasa got trampled by 600-pound wildebeest. But did you know that he was never killed by the stampede? As you can see, the scene cuts off with Mufasa falling towards the charging wildebeest. Therefore, many people assume that he was killed when his body was crushed repeatedly. But the question is whether the fall killed him first or not.
Mufasa doesn't seem to be that high off the ground, but if you look at an earlier scene, the cliff is clearly high enough to cause damage and/or death. According to PBS.org, a force of 3,000 newtons is enough to break Mufasa's spinal cord, which would consequently kill him. We will assume that the impact time is 0.1 seconds. So, was the force impulse applied enough to kill?
So we have him falling. Let's take the time. Looks like it's about 5 seconds. So we know the acceleration of gravity, which is 9.8 meters per second squared. And in this case, we want to find the distance of the fall. So let's take Mufasa's displacement using the equation, which is displacement of x times is equal to velocity initial times time plus half at squared. So the initial velocity is 0 because he starts at rest. So displacement of x is equal to half of the acceleration times time squared. That's also, if you substitute it in, displacement of x is equal to 1/2 times 9.8 meters per second squared times 5 seconds squared. And therefore x is equal to 122.5 meters. With that, we can now calculate the final velocity, and through that we'll use the timeless equation, which is v squared final is equal to v squared initial plus 2a displacement of x. So the initial velocity doesn't matter because it's 0, and the final velocity squared is equal to 2 times 9.8 meters per second times 122.5 meters, which equals 2,401 meters squared per second squared. Now, in order to find the initial velocity without the square, we take the square root of both sides, which gives us 49 meters per second.
Now we find the change in momentum, which is also the force impulse. Momentum is mass times velocity. This is also equal to the force impulse, which is force times time. The mass of an average adult lion is 187.5 kilograms, and the change in velocity was 49 meters per second from the instantaneous velocity right above the ground to the ground. This gives us a momentum of 9,187.5 kilograms meters per second.
We need to compare this to the force impact, which is the same as change in momentum. If the momentum is greater than the necessary force impact to break the spine, then Mufasa dies. If not, then he survives. So the force impulse is force times time, and that means the force impulse in this situation is 3,000 newtons times 0.1 seconds. So the force impulse is 300 newton seconds. This is the same as 300 kilogram meters per second, and that is much less than the 9,187.5 kilogram meters per second that Mufasa felt when it hit the ground. Long live the king.
This means that Mufasa definitely broke his spinal cord when he fell down, and because it controls breathing, he kind of died from the fall and not a stampede. So whether you interpret his falling down the hill as suspicious because he flew backwards and didn't roll downhill, or you are a terrible monster who killed Mufasa, at least the wildebeests who trampled him have no blood on their hands. So thank you for watching.